Welcome back, database enthusiasts. This is Sheila, and you're listening to Database Internals Crashcasts. Before we dive in, I'd like to remind our lovely listeners to rate our podcast on whatever platform you're tuning in from. Your support means the world to us. Today, we're continuing our journey through database architecture, and we'll be exploring N-tier architecture. Victor, are you ready to unravel this multi-layered concept?
Absolutely, Sheila. I'm excited to dig into N-tier architecture with you and our listeners. It's a fascinating evolution from the architectures we've discussed in previous episodes.
Great. Let's kick things off with a quiz question for our listeners. Here's a brain teaser. In a typical N-tier architecture implementation, how many tiers are most commonly used? Is it A, 2, B, 3, C, 4, or D, 5? Think about it, and we'll reveal the answer at the end of the episode.
That's an intriguing question, Sheila. It really makes you think about the practical implementations of N-tier architecture. Without giving away the answer, I'd say it's a great way to get our listeners thinking about the balance between simplicity and functionality in database design.
Absolutely, Victor. Now let's dive into our main topic. Could you give us a basic definition of N-tier architecture?
Certainly. N-tier architecture, also known as multi-tier architecture, is a way of organizing software where different parts of the system are separated into distinct layers. The N in N-tier represents the number of layers, which can vary depending on the specific implementation.
That's interesting. So, how does this differ from the two-tier architecture we discussed in our previous episode?
Great question, Sheila. The main difference is that N-tier architecture introduces one or more middle layers between the user interface and the data storage. In two-tier architecture, we have a user interface that directly communicates with data storage. N-tier architecture adds intermediary layers, typically for processing information and applying business rules.
I see. So, if I understand correctly, it's like we're adding more floors to our database building. Could you elaborate on that analogy?
That's an excellent analogy, Sheila. Let's think of N-tier architecture as a multi-story building. The ground floor is our data layer, where all the information is stored. The top floor is our presentation layer, where users interact with the system. In between, we have one or more floors representing our application layers, each handling different aspects of processing and business logic.
That makes it much clearer. Thank you. Now, could you walk us through the typical layers in an N-tier architecture?
Of course, in a typical N-tier architecture, you'll find three main layers. 1. Presentation layer. This is the user interface, where information is presented to the user and user input is collected. 2. Application layer. Also known as the business logic layer, this is where data processing occurs, business rules are applied, and the core functionality of the application resides. 3. Data layer. This is where data is stored and retrieved, typically involving a database management system. In more complex implementations, you might see additional layers, such as a service layer between the presentation and application layers, or a data access layer between the application and data layers.
I can see how this separation of responsibilities could be beneficial. What are some of the main advantages of using N-tier architecture?
There are several key advantages to N-tier architecture. 1. Scalability. Each layer can be expanded independently, allowing for more efficient resource use. 2. Flexibility. Changes can be made to one layer without significantly impacting the others. 3. Security. With multiple layers, it's easier to implement security measures at different levels. 4. Reusability. Components in each layer can often be reused across different applications. 5. Maintainability. The separation of responsibilities makes it easier to maintain and update specific parts of the system.
Those are compelling benefits, but I imagine there must be some challenges as well. What are some of the pitfalls or misconceptions people might have about N-tier architecture?
You're right, Sheila. While N-tier architecture offers many benefits, it's not without its challenges. One common misconception is that more tiers always equal better performance. In reality, adding tiers can introduce complexity and potential points of failure. Another challenge is the increased network traffic between layers, which can impact performance if not managed properly. There's also a learning curve for developers who need to understand how to design and implement multi-tiered systems effectively.
Those are important considerations. Can you give us an example of a real-world implementation of N-tier architecture?
Certainly. A classic example of N-tier architecture is a modern e-commerce website. The presentation layer would be the web interface that customers interact with. The application layer would handle things like user authentication, shopping cart management, and order processing. The data layer would store product information, user data, and transaction records. Many enterprise-level applications, like SAP or Oracle e-Business Suite, also use N-tier architecture to manage complex business processes across large organizations.
That really helps put it into perspective, thank you. Now, as we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Absolutely. The most common implementation of N-tier architecture is actually a 3-tier architecture, so the correct answer is B. 3. While it's possible to have more tiers, 3 tiers, presentation, application, and data, often provide a good balance between separation of concerns and manageable complexity.
Thank you, Victor. To summarize what we've learned today, 1. N-tier architecture separates an application into multiple logical and physical computing tiers. 2. The most common implementation is 3-tier architecture. 3. It offers benefits like scalability, flexibility, and improved security. 4. However, it can also introduce complexity and potential performance challenges. 5. Real-world examples include e-commerce platforms and enterprise-level applications. Remember, listeners, while N-tier architecture can be powerful, it's essential to consider your specific needs when deciding on an architectural approach.
Excellent summary, Sheila. I'd just like to add that understanding these architectural concepts is crucial for anyone working with databases or developing large-scale applications.
Absolutely, Victor. And to our listeners, we hope you found this episode informative and engaging. If you did, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, keep your queries optimized and your data integrity high.